Okay, so we're talking about the squirrel that's running up and down a tree, and the graph shows the height of the squirrel as a function of time. So what is the range of the function? What's the y values for this function? Good. The height. Okay, so our y values are the height. What's the lowest height that we got going on? 0. Okay, what about the highest height? 14, right? That's how high that squirrel goes. So the range is going to be from 0 to 14. Now, what does that represent? It represents height, but height of what? How's the height the squirrel goes? So he goes from the ground to somewhere in the tree. That's 14 feet off the ground. What about the y-intercept? What's the y-intercept for this graph? It's in between 8 and 10, which is 9. 9. So the y-intercept is going to be 0, 9. Okay. Can you grab that for me? Then yesterday we talked about decrease, right? We talked about intervals of decrease. So right here is where it's decreasing. Well, when is that happening? That's happening between, okay, so like 1.5 and 4, right? So decreasing from 1.5 to 4. And what does that mean? What is this part actually doing? What is the squirrel doing? Climbing down, right? Climbing down off the tree. Yesterday, we talked about that little scooter problem, and we talked about slope-intercept form. So I want you to identify the y-intercept, the slope, and what g of 10 is. Do these three things really quick. So let's identify the y-intercept from this equation. How did you know it was 2? Yeah, slope. Okay, so 2 is the b value, right? So 2, and it's the b value. And what does it mean in this situation? Money, what much, how much money? $2 for what? Is it 0.5 seconds? To get the scooter, it costs $2. So to get the scooter, it costs $1. I'm sorry, $2. Now, what is the slope? Yes, ma'am. 0.5. All right. And we know that because that's the m value. And what does it mean in this situation? How much does it cost for 1 minute? Go ahead. 50 cents. So it costs 50 cents per minute. So we have 50 cents per each minute. 2 was the cost of getting off the scooter, right? Now, how do we find g of 10? Yes. Okay, so we're gonna plug in 10 in for x. So 0.5 times 10 is 5. 5 plus 2 is, okay, so it's gonna cost me $7 for 10 minutes. Okay, really quick. So tomorrow, I need y'all to pay attention because you're gonna miss it. Tomorrow, you're gonna do a mastery check over function notation. If you can do number 3 and you know how to interpret it, then you should be good for tomorrow. Okay? If you don't know how to do that, we need to go back and review a little bit. Okay? Another thing, some of y'all are missing your About Me PowerPoint slide. I'm starting to put those grades in. So if you're not done with that, you need to make sure that you take care of it. For those of you who like transferred into the class a little later, I think I put it EXC, which is just excused. But if I made a mistake, let me know. If you did not do it, what I put in the grade book is an NTI. That goes in as a 0. So I need you to make sure that you got that done. If you didn't finish, go back and get it done. Okay? I'm working on putting those mastery checks in. I try to get your grades in about 24 to 48 hours. That's my goal. Okay? Okay, so today we're going to talk about linear functions in context using function notation. Okay, so a college student is choosing between 2 data plans for her new cell phone. Both plans include an allowance of 2 gigabytes of data per month. the monthly cost of each option can be seen as a function and represented with an equation. Okay. So in each function, the input X represents the gigabytes of data used over the monthly allowance. The student decides to find the values A of 1 and B of 1 and compare them. So how do we go about finding A of 1? What would we do? Plug it in. Is there any X value over here? No. So A of 1 is going to equal 60. Hey, gentlemen. Come on. We're going over this stuff. Y'all should be writing this down. B of 1, we're going to plug that in for this X value, right? So we're going to get 10 times 1 plus 25, which will give me 35. So which plan is cheaper? Okay, so B of 1 is cheaper. Can you go ahead and try number 2? So A is 7.5. What would I get? Go ahead. 100? Is there any X value that's over here? No, right? So here it is again. If there's no X value in this equation, it's going to cost me $60 no matter how many gigabytes I use, right? Okay, here it is again. Pause. If I have no X number or X variable right here, that means no matter how many gigabytes I spend, it is going to cost me $60, right? So it's going to be 60. If I do B of 7.5, oh, you were doing a B of 7.5. Okay, so B of 7.5 is 100. Correct. Exactly. All right, so which one is cheaper on this one? 8.5. Okay. Yeah. When you graph this first one, you're going to type in a Desmos y equals 60. On the second one, you're going to get y equals 10x plus 25. So you're going to graph both of these equations. Draw it on your graph. I'll give you a minute. Okay, so if I graph the y equals 60, this is going to be a straight line across. And then if I graph 10x plus 25, it's going to look something like this, right? Ta-da. Now, describe each data plan in words. For instance, guys, I'm not talking for my health. Okay, describe each data plan in words. For instance, like when you go to T-Mobile, you don't like ask them, hey, what's the equation for your data plan? Like that's not what happens. They say it's $60 for unlimited data, right? And that's what's described in option A. So in option A, it's $60 for unlimited. No matter how much you spend, it's going to be $60 the entire time. Now, option B starts with, they start with $25, and then it's $10 per gigabyte. So which one should you choose? Which plan should you get? Why? Okay. B might be good for what? Short plans or not that much gigabyte use, right? So B would be good for small gigs, and A would be good for larger. Because it would only be $60 and you could get like 9 gig, right? So cell phone company costs $15 per month plus $20 per gigabyte. Okay, a lot of y'all I'm seeing are putting D. No. Okay, so let's talk through it. We've got $15 per month, and then it's $20 per gigabyte. So that's going to be this guy right here, which is C. Huh? I know. Okay. For my people who weren't paying attention, okay, it was asking for the monthly cost and then they give you G, which is the number of gigabytes. So this is like saying X, and what is that multiplied by? That's 20. Does that make sense? You got to be real careful with how they word this. All right. What I'd like for you to do is go ahead and go to student.desmos.com, student.desmos.com. All right, go to student.desmos.com. Okay, and I'm going to hide some of these so you don't have to do them. Yep. Okay, so go ahead and take a couple minutes. Go ahead and do this little card sort. You're matching up the graph to the equation. And then go ahead and fill in the other slides. There's only 6 slides, so it shouldn't take you that long. I'm going to give you about 15 minutes to do it. If you have an X next to your name, it is not correct. Yes, sir. You don't have a computer? You just if you did not get them correct, those are the answers up on the board. Okay. We need to be able to identify the graph. Okay. We need to make sure that we can identify the graph. On number 2, a lot of y'all were giving me some crazy stuff. So let's take a look at this. Coefficient of 2. How do we see that on the graph? Well, this is that rise and run. Okay. This is your slope. This is how like steep it is, right? Now 3 on your graph is going to be your y-intercept. That's all I'm looking for. Okay. Okay, so we're going to switch gears just a little bit. Go ahead and take out this paper. Okay. Go ahead and take out this paper. 1 second. Stop. Okay, so this paper right here, you got this last Thursday. So maybe check in your book bag. If you didn't get it, there's 1 copy right there on the floor right there. I can print out some more as well. But I want you to work with your table group for about 10. Which one does not have a domain of negative infinity to positive infinity? Okay, so domain is your X values. Okay, and so all of these have negative infinity to positive infinity, except Cecilia, which one? Square root. Square root, because the domain is from 0 to positive infinity. Okay, look at that handwriting. Boom. The next one everybody asked me about, increasing and decreasing. Increasing means that our y values are going up. It's almost like a roller coaster. Think of like Goliath, like going up and then going back down, right? So for instance, quadratic, we're going down and then we're going up. So we decrease and then we increase. So quadratic, oops, JK. Quadratic, and then also what's the other one? Absolute value. With the intervals, when we're decreasing on this side. So that's from negative infinity to 0. When we increase, we're going from 0 to positive infinity. Same thing for absolute value. Next one might have tripped you up a little bit. Negative and positive values. If you are positive, you're going to be above the x-axis. If you're negative, you're going to be below the x-axis. So we're looking for something that has both positive and negative. So it's above the x-axis and it's below. Well, which one does that happen on? Linear and cube root. So when is it below the x-axis? Well, from negative infinity to 0. And then the positive is from 0 to positive infinity. Same thing with the cube root. Probably because the notation, when I say something along the lines of y is greater than or equal to 0, That's the same thing as saying, bro. That's the same thing as saying 0 to positive infinity. So which one has that range? That's going to be quadratic. J. Michael, you need one, babe? No? Oh, okay. Absolute value. And exponential. Now, which one has a y-intercept that is not at 0, 0? That one gets exponential. And the y-intercept is going to be 0, 1. Which one is the only function that has a constant rate of change? Linear. And what's the constant rate of change for the parent function? That's slope. What's that number that's out front? There's nothing written there, so we assume it's a 1. Okay. In our function f of 2 equals 2, who are we? Well, if we have this equation and we plug 2 in here, are we going to get 2? Huh? If we have y equals x and we plug in 2 for x, are we going to get y equals 2? Yes. So linear, that would work. What other function would that work for? Not quadratic. Absolute value. Yeah. Girl. Someone come get their friend. 7 into this equation. What am I going to get? Somebody tell me what I got. Oh. What? 26? Okay. And then explain what it means in this context. Yeah. That means that at 7 gigabytes, how much does it cost? 26. Okay. If you can do this, then you should be okay tomorrow. It's over function notation. Okay. All right.